the notion of quantum reality actually comes from Einstein in a certain sense. He talked about a quantum state. He said, is the quantum state real or not? And a good example is the spin of a spin half particle. They'll take an electron. Now, the spin of an electron, the different possible spin states are spin right-handed about all possible directions. So I can move my thumb about the axis, and it spins right-handed about that axis. Now, all those different possible states, those are the possible spin states of an electron. Now, what you can't do is ask the electron what your spin state is, or you can try, but it doesn't give you any answer, because that's a quantum reality. However, if you do have a theory which says by now the electron ought to be spinning, say, about that particular direction, and it has all about the same amount, that's an electron, it's always the same amount, about that direction. Now, what I can do is I can confirm it. And this is Einstein's criterion. I can say to the electron, I'm going to measure the electron spin in that direction. And if I have it right, it will say, yes, you got it right with 100% certainty. And it will not disturb the system. You can measure it again and again and again. And each time it says yes. If I measure it in a different direction, it will give you a probabilistic answer. It will maybe say no, maybe yes, depends on, you do experiment many, many times, and will give you different answers. Now, the quantum state is something you can confirm, in a sense, but you cannot ascertain it. You have to make a distinction between confirming and ascertaining. Ascertaining would be something you say, hello, state, which way are you spinning? It doesn't answer questions like that. But you can explain these rather puzzling things, which is what Einstein was worried about, in fact. These things called Einstein Podolsky Rosen experiments, where you can have a spin state which is shared by two observers or two people, let's call them, widely separated. And you know what the total spin, each one has a spin half particle, which has come from a spin zero initial state, and so they have to be opposite each other. Now, if one of the individuals measures the spin in some direction, that instantly makes it the opposite, actually worse than instantly. It goes backwards in time along the past light curve. And the other one is fixed by the measurement made by the one. And the other one, if that other one could ascertain what the state was, you would then have a contradiction. You could send signals faster than light. But you can't send signals faster than light. It would lead you into contradiction with relativity. However, what you can do is confirm that state. If the other person knew what the measurement the first one had made, then that measurement could be confirmed. But it cannot be ascertained.